Previous reports have described the progress of the XB-70A from the early stages of planning to research and development, and finally through fabrication. Now, during this report period, a major objective of all previous effort has been achieved through the completion of the first phase of flight testing of ship number 1. Looking back to early July, the testing of its various electrical and hydraulic systems had just been completed, and the XB-70A was moved out of the hangar to the engine run-up area for its final pre-flight checkouts. First on the agenda was fuel system calibration. Cockpit fuel quantity gauges were checked as known amounts of fuel were pumped into each tank. At this time, the airplane's fuel transfer and fuel distribution systems were also checked out. Installation of the flight test instrumentation package was completed. In flight, its 3 tape recorders gather information on the pilot's control positions, control surface movements, and temperatures and hydraulic pressures throughout the airplane. And for the first time, the engines were operated in the airplane. Through single and multiple engine runs, pre-flight crews checked engine performance, thrust control systems, instrumentation, and secondary power systems. The flight controls, previously checked out in the hangar, now perform perfectly on air vehicle hydraulic power. All efforts were then directed toward preparing the plane for taxi tests. The first taxi run was started on 9 August. At the controls were the men who would take command on the initial flights. The pilot, Al White, Chief Test Pilot for North American Aviation, and the co-pilot, Colonel Joe Cotton of the United States Air Force. Some problems were encountered in the hydraulic system and required minor modifications of hydraulic pumps and associated plumbing. The fourth in the series of taxi tests, conducted on 25 August, was a complete success. An initial run was made to 87 knots to check nose wheel steering, brakes, and ground handling characteristics. The high-speed run. It reached a speed of 122 knots. Further checks were made on nose wheel steering and ground handling. The drag chutes were deployed at 122 knots, and moderate braking was applied. Chutes were jettisoned at 80 knots. The plane was stopped with ease through moderate braking. 2 more taxi runs were made, followed by countless checks and rechecks of the various systems and instruments. The XB-70A was ready for the big day, September 21st, 1964. White and Cotton were at the controls. Their mission? Take off from Palmdale, follow a scheduled flight plan, and land at Edwards Air.
5, 4, 3, 2, brake release now.
At 8:38 in the morning, the wheels started rolling. Acceleration was rapid and liftoff occurred under 5,000 feet. With all engines at military power, the climb continued steadily while all systems were checked and controls tried out. With all systems in the green, the gear handle was moved to the up position. The main landing gear has a 3-stage retraction cycle. First, the bogies fold, then the struts rotate, finally retract aft. The gear started into the rotation cycle, then it stopped.
Gear has rotated and stopped, is not folding. Okay, they are static, is that right? They're not moving? That's correct.
The gear handle was placed down. The landing gear returned to its normal extended position and locked in place. The flight proceeded in accordance with an alternate plan to gather low-speed handling and stability information. Because of an indication of overspeed, one engine was shut down. The flight continued unhampered. After an hour of flight in the vicinity of Edwards Air Force Base, a low-altitude pass was made over the runway, then the final approach.
We're going to land out of this one. Okay. Chase, if you obviously see me leveling off a little high, well, let me know, huh?
Hey, firm. I'll give you a countdown from about 50 feet.
Okay.
50 feet. 30. 20. 10. 5. And you're on.
Beauty.
Got fire in the left gear. Left gear's on fire.
The pilots landed, unaware that a brake was locked. The two rear tires blew out and started burning. But there was no difficulty in controlling direction, and the plane was brought to a perfect straight line stop.
Where's the jettison? Jettison.
Jettison. Jettison now, 74.
Looks as though your aft tires are blowing and they're both burning, but not very badly. You've got 3 fire trucks with you.
Fire crews closed in and extinguished the blaze in the wheel area. While the first flight did not proceed exactly to plan, it did prove the takeoff and landing characteristics and showed low-speed handling qualities to be quite favorable. Total flight time was 1 hour and 7 minutes. The brake problem was solved, a faulty switch in the landing gear system was replaced, and the engine overspeed condition was corrected. On the 5th of October, the plane was ready for its second flight. The plan was to collect data at subsonic speeds, then move gradually up toward a speed of Mach 1. After the main landing gear refused to retract on the first flight, attention was concentrated on the underside, the landing gear area.
Here we go with the gear on the count. 3, 2, 1, gear up.
Handle up. There's an opening. Green lights are out. Looks good. Nose gear is up and door locked. Going in the wheel well. And both main gear doors are coming closed, and they're closed, and it looks clean now.
They came up in a perfect retraction cycle, and the doors closed. Gear retraction completed successfully. White and Cotton took the plane up to 16,000 feet for the first series of tests. Wing flutter and stability checks were made between Mach 0.52 and 0.68. Flight remained in the Edwards Air Force Base area. Another climb was set for 35,000 feet. During this climb, at an altitude of 28,000 feet, a caution light indicated a pressure loss in one of the 2 utility hydraulic systems. As a precautionary measure, the landing gear was lowered, and following standard safety procedures, the decision was made to land on the 11-mile-long runway of Rodgers Dry Lake. Touchdown was smooth, rollout perfect, and the brakes operated normally. From a post-flight check, it was learned that a broken hydraulic line had caused the pressure loss. The pilots reported that the plane handled well and as predicted, and that extensive stability and flutter data was obtained. Just 1 week later, flight number 3. Takeoff and climb out were normal, and landing gear retraction was perfect. More handling and flutter checks were made, and with the confidence of past experience, speed was pushed up to 0.95. The afterburners were lit, and the XB-70A pushed past the speed of sound to Mach 1.1. 3 times the plane made the jump from subsonic to supersonic speeds. For a total of 20 minutes, the research plane was above the speed of sound, testing, checking, gathering data. On the letdown to Edwards, it became obvious that the plane had lost some of its paint. It was too thick, it became brittle, and when the structure flexed, some paint broke and peeled off. Pilot comments were enthusiastic. Handling qualities at high subsonic speeds and above Mach 1 are the same. There is no trim change. The systems, engines, telemetering, communications, all performed normally. On the 24th of October, the 4th takeoff was made. As planned, the plane climbed directly to 30,000 feet, and the wing tips were lowered. The folding tips are a vital part of the aerodynamic design. They add stability and reduce drag in supersonic flight. With the tips down at the 25-degree position, full afterburner was selected. From Mach 0.95, the plane moved through the transonic zone and up in Mach number. The test goal of Mach 1.4 was reached, almost halfway to the design goal of 3 times the speed of sound. The XB-70A headed back to Palmdale. Its Phase 1 flight test program had been completed. In just 1 month, over 5 hours of flight testing was logged, with 55 minutes at supersonic speeds. Now it's going into Phase 2 test, a complete proof loading of all control surfaces. When these checks are complete, the research plane will push on up to its design goal, steady cruise at Mach 3 at an altitude of 70,000 feet. In addition to the obvious success of ship number 1, extensive progress has also been made on ship 2 during this report period. Mating of the fuselage was completed, and final installations have started on hydraulic lines and air vehicle and instrumentation wiring. Also within this 6-month period, all fuel tanks except number 5 have been sealed. This represents 91% of the total fuel capacity. Sealing of tank 5 is nearly finished. The use of strips along bulkheads and in corners has greatly reduced the time required to seal ship 2 tanks. Crew compartment wiring is also complete. The pilot and co-pilot instrument and console panels have been pre-fit, and pressurization checks of the crew compartment are underway. On the 4th of August, the night crew moved the left wing into the final assembly area. As with ship 1, wing tank sealing was accomplished with no difficulty. It is these rakish delta wings, combined with the long nose section that help give the XB-70A its part spaceship, part airplane appearance. On the 2nd of October, the horizontal stabilizers, the canards, were installed. These surfaces keep the airplane balanced in flight. They also incorporate flaps, which allow decreased takeoff and landing speeds. Takeoff speeds and distances are comparable to those of current commercial jet transports. In mid-October, the vertical stabilizers were fitted in place. Unlike conventional rudders, these operate on a canted hinge line and at supersonic speeds allow much greater directional control with small movements. By the end of this report period, the last major assembly operation, wingmate, was well underway. A modification was made on Ship 2 to provide improved aerodynamic stability. It was accomplished by adding 5 degrees dihedral to the wings and incorporates a new method of wing attachment. The wing is moved outboard 3 inches and rotated upward 5 degrees, providing the dihedral. Transition sections bridge the gap. They are made from honeycomb panels similar to the wing and wing stub. Each panel covers one structural bay. Between each set of panels is a shear web. Both top and bottom panels are fusion welded in place by a specially developed telescoping welder. The undersurface is observed through a periscope. Through this technique, wingmate is facilitated. It actually takes place section by section. When assembly crews finish this operation, ship number 2 will be structurally complete. On the 23rd of December, the left wingtip was installed on the airplane. The XB-70A folding wingtips are the largest flight surfaces that have ever been moved during flight, each one over 500 square feet in area. Rollout is scheduled for late spring of 1965, with first flight in mid-July. Through flight testing of the 2 XB-70A research airplanes, studies will be made at Mach 3 and at altitudes of 70,000 feet. The experience of sustained flight at these speeds and altitudes will help pave the way towards safe and economical travel in the supersonic transport and the military aircraft of tomorrow.